Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Let's continue the discussion on namespaces and let's talk about conflicts. So here I have a class called dog, which is not in a namespace, and another class called dog that's in the animal namespace over here. And notice here the using animals statement. This means it brings this namespace and makes it available to my program. So the question becomes, when I come to use the dog class here or here in my program, which one will I use? So let's try and understand and dig into this. So here you've got a namespace for the program called my program. So the question becomes, when I now use dog class here, which one will it pick? Will it pick this one or will it pick the ones in the animals? Notice the using animals statement, so both of them become available in my program, but which one will get created? So here, if I run this program, and you can see it has printed woof global. Woof global is over here. Notice this one just says woof and this one says woof global. So how did C# compiler pick the global one? So what this compiler does is, when you request the class called dog, it will go through the root of the program and first look in global namespace. What is the global namespace? It's anything that's not defined within a namespace. So here, this one becomes the global namespace, and this one is in the animals namespace. So this one has a higher priority than the animals, because C# compiler will go in the global namespace, tell me, is there a class called dog? If it is, then basically it will use that. If there is no class called dog, it will then go over to the using statements there and then look for a dog class. So just to demonstrate this, so I'll get rid of the dog from here without changing my program. And if I run it again, you can now see it will pick the wolf from this class over here. So just remember, if you have naming conflicts like this, in this scenario where you're using namespaces and there's a global namespace, C# will always pick the global one as shown here. And if there is no naming conflict, then it will actually revert to using the ones in the namespaces that you define, and importing with using animals statement here. Did you know in C# you can actually split your namespaces? So here I've got a namespace called animals, then I've got some other code over here, and then if I scroll down, you can see that I have the animals namespace again. So what the C# compiler will do is it will combine the namespace animals here and the content within it with the content over here. So it will merge them together. So you can have separation of namespaces. This might be useful when you've got two different files, or you can do it in one file as well. Now, one thing that you need to be aware of with namespaces is a lowercase animal like this is different to animals here, with the lowercase a and the animals here with the uppercase a are completely different namespaces because C# is case sensitive. So in order to make them the same, you just make sure you have it exactly as you have it over here. And what the C# compiler will do at the end is combine the content of this namespace with the content of this namespace. An interesting observation could be made on namespaces. So here I've got a namespace called animals, and that has a class called dog with a bark method, and this is what it outputs. But outside of the namespace, within the global namespace, I have a class called dog, which matches the definition over here, and it's got a bark method too, but it outputs the following, which is slightly different. So the question becomes is, I now have my main program, and I've got the main method here, and when it creates this dog, which dog is it going to create? And you can see it's got the bark method being called here. So the observation and the difference is, this one is in the namespace animals, and this is also in animals, but this one, this class over here, is in the global namespace. So if I were to run this program and find out that the output says just wolf, and that is generated by this method over here, which is in the animals namespace, and the other class actually has the word global in it when it outputs the wolf global line. So clearly this has not created the global version of it. So how do you actually go about creating the global version of this class? So what you need to do is add the following, and you can see I have added the keyword global here. Now notice here that there's an error. It says cannot convert type dog to animals.log. So notice the difference here, which is this one is now referring to the global dog, while this one here is still referring to the animal animals dog. And you can see here, if I hover over, it says animal.dog. Then this one actually says it's global dog.dog. So what you need to do is you also need to append global to the class name here. And as you can observe, the error has now gone away from both. And if I were to run this program now, and you can see the output of it is with global, which comes from the class here, which is not in the animals namespace, and we get this output here. So I hope this clarifies the difference between global namespace and the one that you define, and which class actually gets created. So it's the nearest one to the namespace that you're in. So if you are in the animals namespace and you're creating the class that is actually available within the animals namespace, such as this one we had over here, animals namespace, and we've got the dog class. So this one will get created because the creation of this class actually happens over here, and this happened within the animals class. But if you wanted to access the global one, you would have to use the word global with 2 colons here, and that will let you create the class over here. And then this method is the one that gets executed by the bark method. Hi guys, let's take a look at resolving namespace conflicts within your code. So let's have a look at this namespace here. Namespace is Toyota, and then we've got another namespace Honda. Both of these namespaces have the same class. So I've got car class here, and you can see I've got car class here. I am using the following at the top to bring both these namespaces in and make them available to my global namespace. So here is where my global namespace lives, which is without a namespace. So anything that doesn't have a namespace is in the global namespace. So as you can see here, I have an error here and here. This is because it's saying compiler error, ambiguous reference. And if I hover over, this is the error that we get, ambiguous error. It doesn't know whether to select Honda or Toyota. So how do you resolve this? One way you can resolve this is actually appending it with a fully qualified name. So if we go to quick fix over here, and you can say fully qualify the car, and you select Honda, and then this would qualify it as Honda. And then you can do the same here. Just go quick fix, qualify car, and then select Honda again. And that solves the issue. And you can see there's no longer any error because we are now talking about the Honda car, which is over here. So a better way could be is you alias your using statements here. If I alias Toyota as T car, so here now Toyota is actually T car, and I've named Honda as H car. So both of these are now different. So now what we can do is later on in our code, rather than using the full name. So here, as you can see, I've changed it to H car, and you can see here that I've changed this one to H car as well. And then if I wanted to change that to Toyota, then all I have to do is just change that to T car and change that to T car. And that solves my problem of not knowing or the ambiguous reference error. I'm now using alias for my namespaces, which are at the top. And then I don't have to type the name out fully like this. Instead, I can just use the shorthand alias name that I have defined. So just remember, if you do have naming conflicts amongst your namespaces, you can use aliases within your code like this, or you can use the fully qualified name if you prefer. I like the alias method. I think it adds clarity and you have to do less typing, which is really handy. So if I run this program over here, and you can see that by using the alias here, I get the correct output here. And the same with if I change it to H car, and if I run this, you can see now I've got the Honda Civic over here because it is using H car, which is referenced up here. H car basically means the Honda namespace over here, which means it accesses the Honda namespace over here and the Honda car here, and then it prints the following line within the model function. Let's continue on the concept of namespaces, and let's take a look at partial classes to put it into perspective. So here you can see I've got my form class, and I'm creating an instance of that class, and then I'm calling the 2 different methods here. So let's go over to the my form class over here, which is this window here, and you can see this is a separate file. Notice that the namespace is my app, which matches the namespace here in the program file. It doesn't have to, but we made it the same. If the namespaces didn't match, we would have had to use the using statement here, which is also fine. But let's continue with this. So here you can see I have declared my form class, but notice it is a partial class. So concentrate on the word partial, because what partial class allows you to do is declare a class not in its entirety, but over multiple parts. That's why it's called a partial class. So in this version here, in this file within my form, what we're doing is we're adding a method called show. All it does is writes the title and then prints a message to say the form is shown. But as you can see, the variable title is not defined anywhere here, so it's not there. And if we go over to this file over here, my form designer, and you can see that we do have the my form again. We have the namespace my app. So here we had my my app namespace, and we had my form here as well. So this matches. And notice again the word partial class is being used. And at this point, you probably realize we are declaring a variable called title of string type, and it is public. You can see that it has a method called welcome, which is being printed here by the right line. So this variable has become available because it's declared in a partial class. So it is able to access the variable declared in a completely separate file, but still under the same namespace and still under the same class. And then you can see that the method within this one, this is setup UI, and UI setup is done. So how this all gets put together is when you create the myform instance here using new myform, it will combine the two files, and it will combine the myform class partial class here with the show method with the partial class here and the setup method, and also include the variable. So this could all be declared in one class. But if you want to separate your code out, so different developers could work on different parts of the code. The reason I have called these myformdesigner.cs and myform.cs. If you come from a Windows form development environment, you probably notice that Microsoft themselves within Visual Studio create the sort of structure where partial classes are being used, build up a full class. That's why within the designer, you can set up, for example, the UI elements and where to place them. And the code behind file is this file over here, which does some extra things. So those are partial classes, and that's how Visual Studio is able to put together a form that's in two different files. In designer, you design the user interface, and then the code behind it, the backend, is where you write the code here. So this could be the front end, and then this is sort of the back end of it. So that's how you select your classes. But notice how namespace plays a big part within here in order for this to work, because the namespace has to match, and of course the class name has to match as well. If the namespace was different, then this wouldn't work. So if I had, for example, my app1 in here, you can see suddenly we are getting errors here, and you can see these file names have turned red, saying that the name title does not exist in the current context. So that means is it cannot find it under this namespace. And if I could change the namespace over here to my app, and then this suddenly works. So I hope you understand the importance of namespace, partial class, and what it means. It allows you to select your class out over multiple files if you wish to, or even separate them out in one file. Certain namespaces have sub namespaces. So over here, as you can see, I am using JSON serializer, and here this is in the sub namespace that you need within system.x to access it. If I comment this line out, you can see we now have an error. This is because even though we're using system namespace, the object that we're looking for does not exist within the system namespace. So an alternative is you could alias the system namespace like this up to the text namespace if you wanted to, and then you can use your alias, and then you can access the sub namespaces here. So that you can see this is a namespace. So that you can see you can then alias it like this, stmm, which is the alias up here, and then you can use the JSON namespace, and then can access the method or the object that you need. So this isn't the best practice. I just wanted to show it to you so you're aware that this is what you are able to do. If somebody is using this technique, then that's how it works. In C# there are two ways to declare namespaces. So here you can do it at file scope. You can see the file scope doesn't have the curly braces, so it's declared at the top of the file. This namespace over here will be applied to everything within the entire file. So if you had two functions here, for example, or two classes, greeter2 for example, then this would be under the same namespace as defined up here. While the traditional method of declaring a namespace is by using the block syntax. So you can see this is a block of code. Everything within these curly braces is all in one namespace, which is the namespace here. So this is how you declare it. Notice that this one terminates with a semicolon, while this one, there is no semicolon. Instead, you have blocks here, and it only applies to this block. So I could have another class here, for example, and you can see here greeter2 actually now is not in this namespace at all, while in this one, because we've declared the file scope namespace, this greeter2 is going to be in this namespace. And the way you use them, there is no difference in terms of using the file scope one. Again, you just use your using statement there with the namespace name, and you can see here, this is again a file scope namespace, which is my app. So everything within this file program will be in one namespace. And if I go over to this one, you can see how this is laid out differently over here. And you can see in terms of actually using the namespaces, the syntax is the same in both, and there is no difference. So I hope this explains the difference between file scope namespace and block scope namespace, and what you can and can't do within each namespace. This is a nested namespace. So let me just talk you through what nested namespace actually does. So you have your app, and this over here is my app. And then within the app, you've got controllers, you've got services, and you've got models. So you can see here, models are used for data classes. So that's why they are in this models namespace under your app. And then you have services. So in terms of services, that's for the business logic. And I'll demonstrate what I mean by business logic. And then you've got controllers, which manage the flow of the program. So this is known as a model view controller. So if we have a look at our program here, you can see how nested namespaces help. If you didn't have a nested namespace, your program would be like this. So you would just have one namespace called my app, and that would be it, and that would look very messy. You wouldn't know how to locate your code. But by having a namespace with a dot notation, not only does C# provide IntelliSense, but it makes logical sense. So as you could see here, having models for data classes here makes sense. And then services provide the business logic, and then you've got controllers managing the flow. So how do they look in practical? So here, as you can see, this is my app, and then I am using the controller's namespace. And what the controller does is it creates tasks here. So here we are passing it an argument in C# namespaces. Controller also will show the tasks, mark tasks as complete. So if I go over to the controller file, and as you can see here, and what the services do is they add task, but that's using the create task. So it's a separation of logic here. And you can see the controller also prints the line here to say the task has been added, and show task again. This is controller's job, not a service job. So this will actually show you the tasks, and your program, all it had to do was for the show task from the controller. So the logic has been separated. So let's have a look at what services does. So services creates a list of tasks. It is using models, and as you can see here, this is how it actually adds the task, and you can see that it's carrying out some other business logic. So as we said here, that the business logic kind of sits in the services. Notice that it's using models. So what is models? So if I go over to model, this holds all our data. So this is basically just a class with ID title is completed, and that's what the data type is. List is holding the model for the task, and it is appending that model to this list over here. So going back to my notes, that is why you separate out your code in this fashion, as it helps organize your code, and that's why you have nested namespaces. And all we mean by nested namespaces, it just is they have this dot notation. And this provides clarity not only to humans, but actually Visual Studio Code uses the dot notation here just to make it easier for you to find your code. Let's have a look at layered architecture. So as you can see here, I have 3 different namespaces. One called the models. This will be used for data classes. Then I've got services, which is used for business logic. Then I've got controllers. This is for managing the flow. So how do they look in practice? This is what the layered structure looks like. So this is your main program. You've got the main method. And as you can see, we're using a namespace called controllers. So controller is basically what's going to control your entire program. So here we're going to get a new instance of a controller. And what is a controller? That's basically a class. And then using the controller, we can create a task, pass it parameters, then we can use show tasks, we can complete a task, and so on. So if we look at the controllers class, this is what it looks like. Notice that it's using services. So if we go back to our notes, what is service for? So if you look at it's for the business logic. So we're looking at a controller which is managing the flow of the program. So if we have a look at this, what the controller does is it initiates a new service, which is called the task service, and we're creating a new instance of it. And this is the variable we're using. And using the underscore service here, we can add a task. And notice when we use the create task, it got passed a string. So if we have a look at that, create task is over here. It got passed the following string. This string is going to be used here, and then it will be passed further down to add task. And then this is what the controller does. It writes an output to say an item has been added. This is what the show tasks does. So it basically gets all tasks because it's using the service here, and then it's going to loop through and print out all the items within the task. And completing a task just takes in an ID, and then complete task is initiated by the service. So let's have a look at the service. So what is the service? So the service actually is for all business logics. So this is what the service class looks like. So as you can see, we're using models here, and then we're creating an instance of the model class, and this is what the model class looks like. So it just has task, and then it had the following public properties. This is where the business logic sits. So add a task will do the following. So it will create a new task. It will increase the tasks.count, and then it will add a title and mark this as completed as false, and then it will add it to the list over here. And this is what the get for tasks does, and this is what the complete task does. So all the business logic as per a note sits within the service layer, and the controller is just to control the flow of the program, and models actually hold the class that actually defines the object. So as you can see here, this is our complete program. So you have everything being initiated within here, and all it's doing is just initiating the controller. Controller then is responsible for calling the service, and the service actually manages all the business logic. But it uses the models here, and the model is basically the class which holds the properties of the data item that you're looking at.